Global warming. It's a phrase I'm sure that all of you are familiar with. You may not be experts, but you know that it is causing severe climate change on planet Earth and must be stopped. You know that if it is not stopped within the next century, our children and grandchildren may see the end of the world as we once knew it. But how many of you have ever heard of global dimming? It is an equally pressing issue in the climate change of today's world, but is often overshadowed by its counterpart, global warming. Many non-scientists of the world today have never heard the term global dimming. 10 minutes from now, you will all know why it does not in any way deserve this lack of attention. Global dimming is the gradual reduction of the amount of electromagnetic radiation at the surface of the Earth. Measurements began in the 1950s and have been recorded and studied over the past 5 or 6 decades. Humans are indisputably the primary cause of global dimming. Over time, we have caused the amount of aerosol and other pollutant particles in Earth's atmosphere to increase. These particles are causing problems because they have the ability to absorb sunlight rays and the energy they carry, as well as to reflect the light back into space. These particles are even changing the composition of clouds. The water droplets that make up clouds are attracted to these foreign particles. As more pollution occurs, the number of water droplets in clouds increases because the water spreads out into more frequent yet smaller droplets. Smaller droplets have a more intense reflective quality than large ones. This ultimately makes even the clouds more reflective, allowing less sunlight and energy to reach the Earth. The clouds somewhat level out the effects of this, because although their effectiveness varies based on altitude, time, and location, they generally work in opposite ways at night and during the day. They not only block heat from the sun, but they block heat trying to escape from the atmosphere. At night, they keep the Earth's heat in the atmosphere, and during the day, they keep the sun's heat out, creating somewhat of a balance. There has been a great deal of research surrounding global dimming throughout the past 30 years. During the 1980s, Atsumu Omura, working as a geography researcher at the Swiss Federal Institute of Technology, discovered that irradiation at the surface had dropped by over 10% since the beginning of data recording on the matter 30 years earlier. Irradiation is a word used to describe a type of energy produced by the sun, electromagnetic radiation. These initial findings were an enormous contradiction to the already well-known issue of global warming, because the temperature throughout this time period had been rising steadily. A few years later, research conducted in Israel and the Netherlands also concluded that a drop in sunlight reaching the surface was occurring, although this still confused most scientists due to the rising temperature. The specific dimming rate can vary based on your position on the globe, but is estimated to be about 2 to 3% per decade on average. This effect is noticed primarily in the troposphere, the bottom part of Earth's atmosphere in which we live. In the thermosphere, one of the 4 names for the top section of the atmosphere, the effect is microscopic in comparison. Because there is more for the rays to pass through to reach the troposphere, the effect here is greater. We live right in the zone of Earth that is being affected the most by global dimming, the mid-latitudes of the northern hemisphere. A major proof of global dimming is that even though global surface temperature is rising, and one would expect the rate of evaporation to increase, the exact opposite is occurring. The rate of evaporation from water bodies throughout the world is slowing, incontestable proof that there is change beyond the effects of global warming. When products of fossil fuels such as diesel, as well as resources such as wood are burned, they are not completely combusted and therefore give off something called black carbon, composed mostly of soot. This rises high into the atmosphere and therefore does not cause much pollution at the surface, but contributes both to global warming and global dimming because it keeps a lot of unwanted heat in, as well as reflecting sunlight. The clouds containing smaller water droplets caused by these pollutants and chemicals have a much greater effect than the actual particles themselves. Although much of the Earth is warming, places downwind from major areas of industrial pollution have actually cooled. This is seen in the fact that the eastern and western seaboards of the United States are cooling, while the central farmlands have warmed. Some believe that black carbon actually combats global dimming and assists global warming. They believe that it traps solar energy and releases it on areas experiencing glacial melt, such as the Himalayas. They believe that the soot itself darkens ice and snow near the Earth's poles, reducing their reflectivity and allowing more heat to be absorbed. The effects of aircraft contrails, those white trails you see left by jets traveling across the sky, up until about 8 years ago could not be tested. They have a very similar effect to that of clouds, acting in a similar way, reflecting sunlight back into space. One of the main chemicals in these contrails is aerosol. From September 11th to 14th, 2001, all planes in the United States were grounded due to the terrorist attacks in the northeastern part of the country. This gave scientists an opportunity that they may never get again, an opportunity to study the effects of contrails. Their findings were dramatic. They discovered that just like clouds, these contrails were lowering daytime temperatures and increasing nighttime ones. The temperature range increased by 1 degree Celsius in the 3 days that aircraft were grounded. This was proof, once and for all, of the serious effect that aircraft contrails have on global dimming. Ash from major volcanic eruptions such as Ruiz and Pinatubo has been known to cool the troposphere's temperature in areas under the cloud for the short period of time that the cloud exists. The hydrological cycle, more commonly known as the water cycle, has seen firsthand the punishing effects of global dimming. In 2001, researchers at the Scripps Institution of Oceanography performed a study that suggested to them that these effects, due to soot and other particles, were in fact occurring. An atmospheric chemist at this institute, Professor V. Ramanathan, once said, "The energy for the hydrological cycle comes from sunlight. As sunlight heats the ocean, water escapes into the atmosphere and falls out as rain. So as aerosols cut down sunlight by large amounts, they may be spinning down the hydrological cycle of the planet." Some notable changes in the hydrological cycle caused by global dimming include the massive monsoon failure of the 1970s and 80s in sub-Saharan Africa, as well as the Sahel drought, one of many famines caused by the cooling of the Atlantic due to northern hemisphere pollution. Because of this cooling, the rain belt that comes north from the tropics failed to do so, resulting in a lack of seasonal rains. The hurricane season of 2006 was noticeably mild in intensity. Major dust storms in the Sahara of northern Africa sent dust particles across the Atlantic, blocking sunlight that was trying to reach the ocean, causing it to cool and not reach the necessary 80 degrees Fahrenheit or 26 degrees Celsius in order for a hurricane to form. The balance between global warming and global dimming at the surface is causing a more moderated temperature, with less heat fluctuation causing less precipitation to occur, and a more humid and almost tropical atmosphere to result. We need to find a way to somehow eliminate global dimming and global warming at once. If we attempt to combat one at a time, the other will simply get worse. They balance each other, and therefore must be tackled as one problem, not as two separate ones. Scientists are working every day to uncover methods to slow down or maybe one day even reverse the effects of climate change on our planet. But until they do, we need to do our part to slow down climate change and save our beautiful planet before it's too late.